one big application of the polynomial inequalities as well as the rational inequalities is to be able to find domains of various functions. So like I said, now you guys have studied finding domains of lots of different functions since Algebra 1. So when you're asked to find the domain, you can always sketch a picture. If you're not sure what the domain is, the easiest way to do domain is sketch a picture. Or ask yourself, assume that the domain is all real numbers, except is there a particular value you can plug in where the function would be undefined for x? So for example, let's take a look at number 15. This is a polynomial function, and if you remember when you studied polynomials, a polynomial is when all of the exponents for your variables are positive integers. So anytime you see a problem where you have a polynomial, ask yourself the question, is there any value for x that I could plug in that would make it undefined? Can I plug 0 into this function and get an output? Yes. Can I plug in negative numbers and get an output? Yes. Can I plug in positive numbers and get an output? Yes. So polynomial functions, regardless if it's an x to the third, x to the fourth, x to the fifth, the domain is always going to be all real numbers. So ask yourself the question in your mind, what would possibly make this function undefined? Then those particular x values would have to be excluded from the domain. It would be all real numbers except that particular value. So let's take a look at number 16. You have a fraction. What makes fractions undefined when you have what in the denominator, when you have a what? 0. So to find the domain of this function, the domain is going to be all real numbers except where the denominator equals 0. So anytime you see a fraction, the domain is going to be all real numbers except where the denominator equals 0. So what x value would give you 0 and the denominator is going to be what? X equals what? 7. So the domain is going to be all real numbers such that x can't be equal to 7. Well, now the directions say to state that in interval notation. Remember, when you're stating an interval notation, if you're excluding one number from the domain, it's going to be 2 intervals. Think about what the real number line is going to look like here. If I'm excluding 7 from the domain, I know that I'm looking for numbers less than 7 to be included in the domain, numbers greater than 7 to be included in the domain. So I have to write 2 intervals to exclude 7 from the domain in interval notation. So it's going to have to be all real numbers less than 7, and again you're going to put a parenthesis after 7 because we're not including 7, and then all real numbers greater than 7. So again it's going to be a parenthesis 7. So in interval notation, if you exclude one number from the domain, there's 2 intervals. If you have to exclude 2 numbers from the domain, it'll be 3 intervals. There's always one more interval than the numbers you exclude from the domain. So any questions on 15 or 16? Let's take a look at 17. Square roots. What kind of numbers can you not have in the under a square root and remain in the real number system? Negative. We can't have a negative underneath the square root and remain in the real number system. So anytime you're asked to find the domain of a square root function, you always have to take what's under the square root and set it greater than or equal to 0. So it doesn't matter what's underneath the square root. Anytime you see that square root function, you have to take what's underneath the square root and make it greater than or equal to 0, because we can't have a negative number underneath the square root. You can take the square root of 0. What is the square root of 0? 0. So I'm going to take 3x plus 1 and set it greater than or equal to 0. How do you solve that? Subtract 1, and then what? Divide by 3. Just a reminder, had 3 been negative, what do you do with inequalities when there's a negative sign in front of it? Flip it. So don't forget, whenever time you multiply or divide, when you're dealing with inequalities, if it's a negative number, you got to flip it. So then x has to be greater than or equal to negative 1/3. So what am I going to start with, a bracket or parenthesis when I translate this into interval notation? Bracket, and it's going to infinity. Because it's the greater than or equal to. Anytime you're including it, you'll use the bracket. If it's just a greater than, it would be a parenthesis. Okay? So again, you have another square root function here in problem number 18. So we have to take whatever's underneath the square root and make it greater than or equal to 0. So now this goes back to what you had practice doing last night for homework. These are your quadratic inequalities. What are we going to have to do with the left-hand side? We're going to have to do what? Factor it. So that's going to factor into x minus 5 times x plus 3, greater than or equal to 0. So then what are your critical numbers going to be? Your critical numbers will be 5 and negative 3. So I'm going to have to do my number line test. What kind of circles am I going to place above negative 3 and 5? Are they going to be open or are they going to be closed? Closed. Now, what kind of intervals are going to be solutions to this inequality? Greater than 0. Am I dealing with positive or negative intervals to be solutions? Positive. So I want the positive. So I have to pick a number less than negative 3. So I'll choose negative 4. So when I plug negative 4 in, negative 4 minus 5 I know is a negative number. Negative 4 plus 3 is a negative number. And what happens when I multiply a negative times a negative? It gives me a positive. So again, like you mentioned, we're looking for positive intervals. So I know that this is going to be a solution to this particular inequality. Okay? So now take a look at a number between negative 3 and 5. So I can plug 0. 0 minus 5 is negative. 0 plus 3 is positive. So a negative times a positive is a negative. So no solutions between negative 3 and 5. And then if I plug in a number greater than 5, for example 6, 6 minus 5 is positive, 6 plus 3 is positive. So I know that those would be positive, so I know I'll have solutions greater than or equal to 5. So any questions on how I did that number line test? So now I can go ahead and write my answer in interval notation. So all real numbers less than or equal to negative 3 would be negative infinity to negative 3. Is it going to be a bracket or parenthesis after negative 3? Bracket. And then all real numbers greater than or equal to 5 is going to be a bracket or parenthesis before 5? Bracket. So any questions, guys, on number 18? Let's take a look at number 19. Again, you have another square root function. Anytime you have a square root function, you have to take whatever's underneath the square root, make it greater than or equal to 0. So now you have the fractions. So you want to make sure, guys, that you can factor the numerator and denominator if possible. There's no factoring to do. So what you need to do, remember, is to find your critical numbers, you set the numerator and denominator equal to 0. So what x value is going to give you 0 in the numerator? 7. What x value is going to give you a 0 in the denominator? Well, if I take 3x minus 2 and make it equal to 0, what's the critical number coming from the denominator? 2/3. Now remember, what's special about that critical number coming from the denominator? What do we always have to do when I plot this number on the number line? It's always going to be open because remember, this value can never be included because that gives you a 0 in the denominator. So when I plot the critical numbers on the number line, no matter what, the critical number from the denominator is always an open circle. But what kind of circle am I going to put above 7? It's going to be what? Closed. Again, I'm looking for positive numbers to be solutions here. So when I pick a number less than 2/3, I'm going to just go ahead and use 0. 7 minus 0 gives me a positive in the numerator. 3 times 7 minus 2 is going to give me positive in the denominator. So I know that numbers less than 2/3 will give me positive. If I pick a number between 2/3 and 7, so if I use 1, wait a minute, I did something wrong, it's negative. Sorry, 3 times 0 is 0, minus 2 is negative. That's a negative on the bottom. So I'm going to get negative numbers less than 2/3. So no solutions less than 2/3. Sorry about that. But I plug in 1. 7 minus 1 is positive. So I have a positive in the numerator. 3 times 1 is positive, minus 2 is positive. So I do have positive numbers between 2/3 and 7. And then if I pick a number greater than 7, for example 8, 7 minus 8 is going to give me a negative number on the top. 8 times 3 is 24 minus 2 is positive in the denominator. So I know it's going to be negative for numbers greater than or equal to 7. So then my only solutions are going to be from 2/3, greater than 2/3, and less than or equal to 7. Remember, you put a bracket after the 7 because we're including it. Any questions on number 19? So what are we going to do? Again, you have another square root. So what do you take with what's underneath the square root? You're going to do what with it? Make it what? What do we do with it? We're going to make it greater than or equal to 0. Go ahead, guys, and find your critical numbers and then do your number line test. Because again, when you factor this denominator, we know we have the critical number, -1, coming from the numerator. But when I factor the denominator, I can take out my GCF of x, and that's going to give me an x minus 3. And when I set that equal to 0, that's going to give me a critical number of 0 and 3. And again, remember, if they're coming from the denominator, you've got to have those open circles above the critical numbers from the denominator. So any questions on how I ended up with 3 critical numbers? So now when I do my number line test, -1, 0, and 3. What kind of circle am I going to put above -1? Is it going to be open or closed? Closed. Open above 0, open above 3. Again, I'm looking for positive intervals because, again, this is greater than or equal to. So a number less than -1, I'll use -2. Well, -2 plus 1 in the numerator is a negative number. -2 minus 3 is a negative. Times a negative gives me a positive in the denominator. So I know numbers less than or equal to -1 will be negative. So there's going to be no solutions coming less than -1. Again, you have no choice but to choose a decimal between -1 and 0. So I'll choose -0.5. Well, -0.5 plus 1 in the numerator is going to give me a positive. -0.5 minus 3 is a negative. Times a negative will give me a positive in the denominator. So I do know that I'll have positive numbers between -1 and 0. Plugging in a number between 0 and 3, I'll plug in a 1. 1 plus 1 is 2 in the numerator, so that's positive. 1 minus 3 is a negative, times a positive, which is a negative. So I know I'm going to have negative numbers between 0 and 3, so no solutions between 0 and 3. Then if I plug in 4, 4 plus 1 is positive in the numerator, over 4 times 4 minus 3 is positive. So I'll have solutions greater than 3. So any questions on the number line test? So my solution then, when I translate this to interval notation, remember I am including -1, so it's going to be a bracket. -1 to 0. Again, 0 has an open circle with the parenthesis. And then parenthesis 3 to infinity. Yes. Yep. Exactly. Okay? So any questions, guys, on how we can use, again, the number line test and what we talked about last class to help us find domain, especially when we're dealing with square root functions? Remember, the first 2 examples, guys, there was no square root in the problem. So you don't have to take it, and you're not going to set everything greater than or equal to 0. It's only if you're dealing with that square root that you have to make sure you take what is underneath the square root and make it greater than or equal to 0. Okay? So any questions on that? All right. So like I said, guys, your homework for tonight is to